Assalamualaikum and hello everyone. Welcome to the video for 3.2 Nernst equation. Where in this video, we will learn to use the Nernst equation to determine the cell potential and predict the spontaneity of a cell reaction. Okay, previously, we have learned on how to write down the Nernst equation itself. Okay, so here, remember this is the equation that we will use for the calculation. And again, Q must depend on the equation, where the Q must be product over reactant. Okay, so let's look on your notes on page 9. So here it asks you to determine the cell potential. So cell potential is E cell. So because we have to find the E cell, we have to use the Nernst equation itself. Okay, so let's look for the examples together. So let's start with example A here. This is actually our cell notation which follows the ABC rule. So first I'm going to just label my A, B, C. Okay, next, to determine the cell potential, so this is the formula where log must be the log Q, where Q must be product over reactant. The product over reactant, we have to find out from the equation, but where is the equation? We have to write down ourselves the anode, the cathode, and the overall cell equation. Okay, so first the anode is actually our zinc. So from the equation itself, zinc solid, okay, remember that oxidation here, oil, it means that it loses electrons. So zinc solid, from zinc 2 plus equals plus 2 electron. Okay, next check whether the equation is balanced or not in terms of atom and in terms of charge. So zinc for both sides is 1. Okay, when we calculate the charge for both sides is 0. Okay, then we can proceed with our cathode. So cathode, okay, from the cell notation itself, we can see it will form Cu2 plus. Okay, and then for the reduction, it will gain electrons, so plus 2 electron to form Cu solid. Okay, so check whether the equation is balanced. Okay, the atom is balanced as well as the charge. Okay, so right now we can simplify the equation to write down the overall equation by simplifying the electron, which must be the same so that we can cancel it out. Okay, if the electron are not the same, we have to multiply all the equation. Later we will look at the examples. Okay, so here I'm just going to write down the overall equation. So remember the reactant are on the reactant side, product must be on the product side. Write down the state as well because that is important to determine the Q. Okay, so here we can determine our Q. Okay, so Q must be product over reactant. The product and the reactant must be gas and aqueous only. Okay, so right now when we look here, the product itself, our product is here. Copper solid is not included, so our aqueous is zinc 2 plus. Aqueous is the concentration, so we have to use the square bracket. Divide by the reactant, again, solid is not included, so what we have is actually Cu2 plus. So we have to write down Cu2 plus. So this is actually all the formula. Okay, so right now we can calculate the E cell, but before that we have to find each of the formula itself here. E naught cell. Remember, E naught cell is E naught cathode minus E naught anode, where the cathode must be positive, anode must be the negative. So again, I'm going to label the cathode and anode so that it will be easier for us to substitute. Okay, again, cathode minus anode itu pun kakak tolak adik. So the value is positive 1.10 volt. Okay, so for N is actually the number of electron transferred, where the process of gain or losing electron. So when we look here, the gain or loss of the electron involved is actually only 2 electron. So gain or lose 2 electron. So that's why our N is equal to 2. And last but not least is the concentration. The concentration is given in the cell notation. So here I will write down the concentration at the side here. Okay, so now we have found all the values. So what should we do next is that we will substitute into the formula. So the E naught cell, remember, is the kakak tolak adik, positive 1.0. Okay, number of electron transferred is 2 because loss and gain of 2 electron. Okay, and then that is the concentration. Hence, we get the E cell to be 1.14 volt. Positive must be included to show that the reaction is spontaneous. Spontaneous means that the reaction could occur. Okay, so from here, how do we answer this? First, write down the formula. When you write down the formula, then you have to write down the equation to fill out your formula itself. What is Q? Product over reactant. Okay, and then once you have write down the formula, you can write down or find out the rest, which is E naught cell kakak tolak adik. Okay, so how to determine the cell potential? So as you can see here, the concentration of our electrolyte itself is not equal to 1 molar. Okay, so when it is not equal to 1 molar, so we have to find the cell potential. So question 2, try yourself. It's just that for the equation, when you simplify it, make sure the electron are the same. If it's not the same, you have to multiply the equation. Okay, so that's for question B. Let's do question C together. Okay, so this is actually all the information given and the E naught cell. Okay, so first thing first, what we're going to write down is write down the formula. Okay, so what is Q? Q we have to find out from the equation. Which one anode cathode? We're going to find out from the E naught. Remember, negative anode, positive cathode. So even though both is negative, we know that if the value is nearer to 0, so it means that it is more positive. In this case, nickel is our cathode, hence the chromium will be the anode. Okay, so right now we have to write down the equation. Okay, so for the equation of anode, okay, remember when we look based upon this equation, anode is losing electron, but the equation here is gaining electron. So what should we do? Okay, we have to swap the position. Okay, so when we swap the position, I'm just going to write down the equation. So we get here. When we check it, here is lose electron. So ngamlah dengan oxidation kita. So next, check whether it's balanced. Chromium is 1:1 ratio. And the charge is balanced on both sides is where both is equal to 0. Okay, right now it's actually the equation for cathode. Okay, so for cathode itself adalah reduction where we gain electron. So based upon this equation, we do gain electron, so we will just take the equation as it is. Okay, so we do get this equation. Okay, when we check it, make sure the equation is balanced on both sides, the atom and the charge. Okay, next we have to simplify. Simplify the electron must be the same. But right now, our electron are not the same, so what should we do? We have to multiply all the value to get the same electron. So again, what I'm going to do is actually here, I'm going to copy paste it again. Okay, so for this one, we have to multiply by 3. So multiply by, tapi it's 9. So silap. First one, multiply by 2. The second equation, multiply by 3. So here 2, the electron is 6. For the cathode, multiply by 3. So here I have multiplied it. So now we can simplify the electron because the electron are the same, which is 6. Okay, so the overall cell equation, again, we have to write down all over again, the one that is balanced. So if we have new stoichiometry, we have to include it. Okay, 3 nickel solid plus 2 Cr, 3 plus equals. Okay, so from here, from our equation, then we can find out our Q. So what is Q? Remember, Q is product over reactant. Product must be, the phase must be gas equals. Solid is not included. So we have to include the Cr3 plus equals. But then we have 2 in front, so we have to write down to the power of 2. Okay, for the reactant itself, okay, the chromium solid is not included. What we have is nickel 2 plus. But then because we have 3 in front, so we have to write down to the power of 3. Okay, so next, what should we do? So we have to find out each of the component here. So E naught cell, remember, is E naught cathode minus E naught anode. Kakak tolak adik. Where cathode must be more positive and anode must be more negative. Okay, so we substitute all the value together. Hence, we will get the value to be 0.49 volt. And it's actually the number of electron loss or gain, the transfer of electron, is where N is equal to 6. And the concentration is given from the question itself. So we're just gonna write down the value itself here. Okay, so since all the component we have known the value, we can substitute it straight away. So here is positive 0.49 minus 0.0592 divided by 6. Log of concentration of Cr3 plus. Okay, make sure here we have to the power of 2. And then for the nickel 2 plus, it is to the power of 3. So we will get the value of E cell to be positive 0.42 volt. Okay, so that is for question C. Okay, so for question C itself, first is the same one. We have to write down the formula and then write down the equation, okay, to find out our Q. Then we can find our E cell and then we can substitute it. Okay, the other thing for it is that make sure, remember, the anode must be oxidation or oil where it will lose electron. Red cat, weak, where we gain electron. So make sure if the equation is given, check is it correct, the reduction and the oxidation equation. Okay, question D, I believe you could try it yourself. So it's the same. Make sure the cathode and anode, it must be anode oxidation, cathode reduction. Okay, so this one, I believe you could try it yourself. We have learned how to determine the cell potential. Next, we will determine the spontaneity of the redox reaction. So on your notes on page 10. Okay, so for the spontaneity of the reaction, again, it will be spontaneous when the E cell is positive and it will be non-spontaneous when E cell is negative. So that's why it is important for you when you calculate the E naught cell or the E cell itself, you have to include whether it is a positive or a negative sign. Okay, so let's do the question A together. Okay, first let's look for example A. Will the reactions occur spontaneously? Since this is cell notation, it will follow the ABC rule, so I'm just going to label the ABC. Okay, when we look at the question itself, the concentration of your electrolyte is not equal to 1 molar. So that's why you have to find the E cell, not the E naught cell. Okay, so from here, then we can find out the E cell. Okay, again, remember Q must be found out from the equation. So again, we have to write down the equation. Where the anode must be the oxidation process where it will lose electron. So nickel solid will lose electron to become Ni2+. Okay, and then make sure it is balanced, not only the atom, the charge is also balanced. Okay, so that's for anode. How about the cathode? Okay, so for the cathode here, first is the Cl2 gas. So Cl2 gas, remember this is a reduction process where it will gain electron. So we're just going to add electron to get the product is Cl minus. Okay, right now let's balance together. Chlorine is not balanced, so we have to add 2 in front of Cl minus. Next, the charge is not balanced, so we have to add 2 in front of the electron, so it is balanced. So next we have to simplify it, simplify the electron. Okay, then because the electron is the same, so it's quite straightforward. So what I'm going to do is actually, we will write down all the reactant and the product together, okay, to get our Q. So this is our equation. Okay, so from here, then we can find our Q. Okay, so this formula, okay, again, what is Q? Q is actually our product over reactant. So for the product over reactant, it must be gas and aqueous. Okay, so product here, both are and aqueous. So you have to include both. So for the Cl minus, because we have 2 in front, so we have to write down to the power of 2, but nickel 2 plus is quite straightforward. So for the reactant, nickel solid is not included, but we have here for the pressure is PCl2. So this is actually the formula, so we have to find out each of the component itself. E naught cell kakak tolak adik or cathode minus anode. Again, cathode must be more positive, anode must be more negative. So I'm just going to label the chlorine to be cathode, nickel is my anode. So here, we will get the value to be positive 1.61 volt. The number of electrons involved is actually 2. Transfer of 2 electrons, so N equal to 2. Okay, so the concentration here, I'm just going to write down what is the concentration based upon our cell notation. Okay, and then for the pressure itself is given, any first atop pressure given 1 atm. Okay, so from here we can substitute all the values into our formula. So again, just going to write down is equal to positive 1.61 volt minus 0.0592 divided by 2 log concentration of Cl2. Okay, Cl to the power of 2. Okay, but then the concentration of Cl is supposed to be 0.1. So please write down the correct value. But then remember to the power of 2 and the concentration of nickel divided by pressure is 1. So from here we know that the E cell is equal to positive 1.69 volt. Okay, so from here, since it is a positive value, so we know that the reaction is a spontaneous reaction. Okay, so that's for question 2. Okay, again, because the concentration of the electrolyte is not equal to 1, so that's why we have to find from our Nernst equation. Question B, I believe you could try yourself. But since it is negative value, so it means that it is non-spontaneous. So that's it for this video.